It's great to be here today, especially here at NACIS in particular. And I found this quote earlier, never permit the pressure to exceed the pleasure. And it has been a pleasure this week at NACIS, especially with the NACIS is nicest motto. That's definitely put me at ease coming into, whoa, sorry about this. As I've come into this presentation this week. So today what I'm going to talk with you about is the work that I did in my master's program at the University of Kentucky. That's a little bit of proof that, that I earned my Master's of Science in August. My kids are rather proud of this. To me, it's a piece of paper. And the fascinating thing about going through this, learning geography in the last few years, as well as some GIS and digital mapping, was just the opportunity to learn and build on a data background that I have. My presentation is here, and I'll give you, I'll post that at the end of this, at the end of the discussion. So when my kids graduated from high school, they wanted to go to Disney World to celebrate. They wanted the Mickey ears and the hat and the little graduation hat, I guess, to go there. But for me, it was, I opened my mouth a few months ago to Rich Donahue, one of the instructors there, and said I wanted to, that my goal was to speak at some conferences. I don't know why I did that, but I'm glad that my first one is here at NACIS. So what I want to share with you today is what I call commute patterns or spatial patterns in census to origin destination data. And, whoa, not clicking the right thing. Sorry about that. So what we're going to do is we're going to process and transform Census Bureau data to provide insight into commuters' residence, workplace, their earnings, and age ranges, and industry type. This is the final map that I came up with. This was not the overall journey of where I wanted to get in the process of this. I'm more of a data, as I've gone through this program, I'm more into data transparency and how I get to this end result. But I will go over the map with you briefly. I've kept everything as static images, and I'll give you a link to the map at the end of this if you want to get online and kind of play around with the Slippy map. So to just kind of go through it, in the upper right-hand corner, discussed age ranges. We've got 3 different age ranges, 3 different earning groups that you can visualize the data on, as well as 3 different industry types that you can change the maps and see things change. Also, add in some background to it, and we can add some labels to it. And of course, in the bottom left-hand corner, we can zoom in on particular areas, and this is the area of Washington where we are today. So the big question when I get to a lot of these visualizations that I see online is how did they do this? Of course, easy enough. You can go in and start playing around with the back-end information. You can see the page source, the CSS, and the JavaScript code that's behind it. And with this particular map, you can even go into Mapbox and look at the data where I dumped the final product of the data. But unfortunately, that's just going to give you the line strings that are drawn between these points. So what was the journey to get here to produce this? And that was my goal with this project, to create something that was visually appealing. Others have done this. They've done it in static maps more regionally. One of them that was inspirational to me did the state of Indiana. There's been research done on how to best make this data look the way that I've made it look, but nobody really documented the process of how do you get the data and how do you be able to analyze the data on your own. The next goal that I had in this was that I wanted to play with a large amount of data. At first, when I looked at this, I really thought, wow, this is going to be too easy. The Census Bureau's done everything for me. But wow, I was not prepared for the amount of work that I was going to have to put in, but it was a lot of fun. And then I wanted the process primarily to be complex enough that it could be something that would warrant documenting and being able to share with others through GitHub and allow them to be able to pull in the data. So the primary data source is called the longitudinal employer household dynamics data, loads for short. It consists of, a lot of times you think that the Census Bureau just puts out data every 10 years, but that's not the fact. They have an awesome amount of data that you can get in and pull down and play with. And hopefully the processes that I've gone through this will allow others to be able to do something similar even with some of the other types of data that they have on there. But so you can see that it's quarterly census, employment wages data. A lot of the data comes from the state, and they wrangle that together and they try to put it out every year. The purpose of loads is to help users understand, analyze, and visualize where people work and where they live. So the data itself, when you go to their repository, you can see that there's two types of origin destination data. There's a main and auxiliary. Main is everybody that lives within the state and works within the state. Then there's auxiliary files that contain those that work in a state but live outside of the state. There's also six more different files within the OD and AUX for each one that have these type of jobs. So what I'm pulling in with this data set is going to be all the primary jobs for everyone and the OD AUX records. This is the part where I got to that I thought, wow, the Census Bureau's done this for me and this is going to be really easy. But when you look at it, the HGO code and the WGO code are the home and the workplace. They're down to a block group level, so you can get into a very small area. One of the things that I'm going to continue on with this is I can identify down to the block group level to see where the University of Kentucky Hospital is, as well as the University of Kentucky, and I hope to do a little bit more analysis with showing some visualizations with the commute lines here. But anyway, that's another project. So we also have an ability to aggregate the data based on the three areas that I discussed. Total number of jobs is going to come into play here in a minute as I begin to filter the data, and I'll go over that. And we have the age ranges, the earnings, and the industry sector as well. So my data wrangling tools that I used. Primarily in the program, at least right now, that could change in the near future, and that's one of the cool things about the digital mapping program is that they're constantly on the kind of bleeding edge almost of things. But Jupyter notebooks and Python were the primary tools that I've used to do this. And I'm going to go through the real quick here the data flow workflow that I use. So you can see across the top, we're getting the OD and AUX records. We're going to bring those into a CSV file. Along the bottom, I'm going to be able to, I need to know all the centroids for all the block groups within the nation. So I'm going to demonstrate how I pulled in that data. Then we need to merge those two together. So I'm going to take the HGO code and the WGO code, and for each one of my points, I'm going to build out a data file that I can filter on a little bit further, be able to output GeoJSON, and the end result will be the map. So within the Python processing, I'm primarily using Pandas and GeoPandas. And this is a screenshot of my repo within with the Jupyter Notebooks folder. These things are highlighted in there. The process, I attempt to document that as well as I can. So the first notebook that I want to go through, I'm just going to go through the code instead of scrolling up and down here through my notebooks, but that's actually one of the notebooks that we're going to discuss, but I just want to highlight some of the code to eliminate a little bit of the confusion, I hope. So one challenge that I faced right off the bat was the Tigerline files are on an FTP site. That was a little different than anything that we had worked with just downloading CSVs. So this was some steps in order to establish the connection with the Census Bureau and begin downloading the files that are there. I'm going to loop through each one of the state files, and that's highlighted here in this code. I develop a lot of functions that I'm going to discuss one here with extracting it, and you can see that we unpack it, and then as all shape files, they're going to come with multiple things within them. So I'm going to have to assign some file handles for those files, and the only thing that I really want out of this is the data that exists in the shape. So I'm going to build what's called a geodata frame here. This is another function that's called to get the data. I'm going to go through, and as I build through that, all I really want is the GeoID. I'm setting the example here, I'm setting the Latin long to float. So we're just building out the data frame, basically an Excel spreadsheet. When I get the data frame built, I want to send it to what's called a Python list, and that's a function here that we're doing, that we're calling. And in that, before I create this, append the list with the data as I'm going through each state, I don't want any of the water records, so that's my first filtering kind of to get out. I do some checks to make sure of the validity of the data record is a state. And then I want to get rid of it. I don't want this on my laptop. I don't want all these files. As you know, shape files can consume a lot of space, so I write to a temp area. I create these lists of the data that I want, and then I'll remove it. I don't want them anymore. So processing total for just this piece to FTP down the data and get 10.5 million records back took 268 minutes. I do a lot of counting and timing through all this, and you can see those in the Python notebooks if you want to go to the repo and look at it. So the next step, I'm going to get the OD Aux records. This is a little bit easier because they've got them up there as CSV files. So we're going to loop through all the states. I've got a line here that makes the connection through HTTPS. We're putting in the state and just building out that long string in order to get to download the zipped CSV file. Do a file check to make sure that the file actually exists before I go out there and get it, so that the program itself the Jupyter Notebook doesn't crash and give me an error. There are some states that don't have data for their ODX records, and it changes annually, and that's documented on the Census Bureau site. So I've got a function that we go out that does all this. Again, we build a data frame, we build a list, and what we're doing is we're creating the CSV file again to write out. Total time for this was a little bit faster. It's 23 minutes, but we downloaded a total number of records in my list was close to 118 million records. It's a lot of data with the end result trying to be a slippy map at the end. So I need to merge these two together. I need to take the OD AX records along with the centroids to get so that I want to, in the end result, build a line string. And I'm going to speed up a little bit here and just kind of step on to the next step. And let me make sure here. So one of the things that we want to, that I want to do, because we have 118 million records that we're going to process, you can see here in 7, 8, and 9, I'm doing something called chunking. So I'm going to chunk in 10 million records at a time. I'm going to process them through as we go, and that's going to save the memory on the computer to be able to just flood this little laptop with 118 million records and try to build out the data frames and everything. That doesn't work very well, so I use chunking. When that's done, Another thing that I want to highlight here, nope, it's in this step. So we want to write each age, and the age, the earnings, and the industry types to GeoJSON files in order to create the line string. And this bit of code right here is doing that as well. You can see that we're bringing in the Latin longs from the CSV files that we've created. When we're done processing, we're going to wind up with this number of, for each age group, the number of records. And as we can see, as we page down through here, the second age group actually contains about 5 million records. So we're still kind of pushing the boundary here of what a Slippy map's going to be able to entail. But we've built the records in the GeoJSON. We've still got too much data. GeoJSON's a little bit too large. My end result was going to be to do it in Mapbox Studio. It can't handle GeoJSON files that big, so I need to create tile sets. And in order to use tile sets, Mapbox has a documented process that you can use a tool called Tippecanoe that allows you to build out the tile sets. I need to build out 9 tile sets, 3 for age, 3 for industry, 3 for earnings. This is an example of the code. It's documented again on the repo of how to build out these MB tiles. And the final steps, we upload the MB tiles to Mapbox, write a little bit of JavaScript code to create the Slippy map. I used VectorGrid. I didn't use Mapbox GLJS. That's another project that in itself that there just wasn't time to get in and use, but it was kind of fun to fool around with VectorGrid. It's new. I'd like to regionalize some of the data as I discussed earlier. So this is the repo, the presentation, and you can get to the map in this area. I want to give a special shout out in my final minutes here to the instructors and the staff at the geography department at UK for putting up with me and being a total noob in this stuff, but it was a fantastic learning experience. And if you want to ask more about the New Maps Plus program, catch me later, and I'll definitely be an ambassador for that program. So any questions? Michael. Yes, that's correct. They were vector tiles. She's asking what. There's a statistical workbook that I wrote that I did that, but no, over the months of getting this ready with my primary goal just being to document the process. So that's another thing that needs to be done with the data, is to look for the patterns and do more analysis with it. So that's another fun step for me to look forward to in working with this. I don't get to work enough with spatial data in the job that I have at the University of Kentucky, so that's where I hope to go with this as well. Great question.
Okay, thank you.
Thank you all.